Hello everybody, welcome to today's Tech Talk where I am going to discuss about how to work smarter with OpenSTAAD. My name is Surajit Ghosh and I work in the Structural Technical Support Department of Bentley Systems and work with various STAAD and Ramline products. It is required for us to exchange our data with STAAD to any other software that might be any Bentley product or that might be any third-party software like Excel that is used basically by the engineers who use their some in-house programs or some advanced codes. So today's agenda is first of all I will discuss about what is OpenSTAAD and what language and platform we can use to write our code for the OpenSTAAD using the OpenSTAAD functions. Then I'll discuss about the operations that we can perform using the OpenSTAAD function. So I'll discuss about what type of things we can do using this particular OpenSTAAD functions, what are the limitations of this particular function, and how it can be beneficial for our daily job. Means if anybody is using the STAAD any version of STAAD, basically the connected edition version, how he can be beneficial using the OpenSTAAD version, the input and output format. So basically where we can write our code and where we can get our output or from where we can extract our results. So I'm going to discuss all about this, and finally I'm going to cover where from we get any help if we need any help regarding the OpenSTAAD function, where from we can check the information. So this is basically what I am going to cover today. Let's start with OpenSTAAD. So what is OpenSTAAD? For any program, whether that is any simple program or that is any web program, developers have the access to the particular source code of this that particular program, and they provide some options for the users. So basically, when we are using that particular program, we are accessing that particular source code. We don't have a direct access, but we have the access to the source using some options that has been provided to us by the developers. Basically, using those particular options, most of our needs are fulfilled. But what happens if we want to do some more activities using that particular program? So we don't have any options because the developers don't provide any options thinking about that particular specific situation. So we need to access that particular source code to do that particular thing. There is a backdoor to access the source code without tampering that particular source. That particular thing we can access using this particular API functions. For example, like the common example is like the Android API or the Facebook API. For example, like we can see that there are several games or applications that we can install in the Facebook platform or in the Android platform. This particular tools has been created using that particular backdoor or the API functions. For STAAD also there is an option that is called OpenSTAAD, using which any user can access the source of STAAD. He can do some things that the option which is not available in STAAD or that might be available, but we have some other options we can generate using some macros or codes. So OpenSTAAD is basically a library of functions that is accessible from any other third-party program. Basically, we need to write some codes using the OpenSTAAD function. So we need some knowledge about the programming, not in-depth knowledge, but we need some basic knowledge about the programming. Normally any components calling programming languages can be used for this particular OpenSTAAD writing or the code writing. Some of the most useful or the most used programming language are highlighted here, like the VBA or the VB.NET or any C or C++ or C# programming language can be used for this particular code writing. In my presentation I am going to use the VBA language because it is the most simplest language and we have so many options, so many help available in the internet. So if we don't know about any programming language, we can start with VBA, and if you need any help regarding how to write a code in VBA or how to get any function, how to access this particular VBA, we can get any help from the internet. What are the platforms in which we can write our code, or basically what I want to say is that which softwares we can exchange our data. Any VBA compliant software can be used. That might be the VBA editor that is provided with STAAD. So we have a VBA editor in or the script editor that we call available in STAAD.Pro. So we can write our code there and we can exchange our data using that particular code, or we can write our code in Excel or Word VBA editor, so that we can just exchange our data or the extract our results in the Excel directly. We can use any other CAD products, like if you are going to create any geometry and you want to import that particular geometry to STAAD, we can do that using the VBA editor or the script editor that is available in that product, like the MicroStation or AutoCAD products. So using the MicroStation VBA editor, we can just write our code there. We can use some OpenSTAAD function to access that particular information from MicroStation to STAAD.Pro, or the other products like the MathCAD or MATLAB, where you can just write some advanced math functions, and that might be helpful for our design or the creating of the geometry. And using this particular VBA or script editors or the other editors like the Visual Studio, where we can write some advanced code. So if you want to create some tool or some .exe file, you can write your code in the Visual Studio environment also. So now let's discuss about the operations that can be performed using the OpenSTAAD function. So starting from creating the geometry or assigning any property or specification up to assignment of loading and design parameters, each and every item can be achieved using the OpenSTAAD function. So think about a situation. You are going to create a steel structure where you are going to create the geometry, the truss that is located on the top of the structure. You are going to assign some sections, you are going to assign some member release, assign some loading and everything. So each and every activity can be done using the OpenSTAAD function. Yeah, not necessarily you need to create a model where you need to write all the functions and you just need to run that particular code so that the model is created. Not like that, but depending on your requirement, you can write your code. For example, like you want to don't want to create a user table so for each time to create a user table, you need to go to the STAAD.Pro user table option and provide the value, select the type of members that you are going to create. You don't want to do that one. You have some data probably provided by your contractor uh, or the person who provided you the design specifications. So you have the data, you want to create it directly from the Excel or directly from Word. So you can just write your code there. You can just create your user table, and just that particular user table will be written in the STAAD format. So you don't need to copy the value from there and paste it in the STAAD user table or the input editor to create a new user table. So that can be eliminated using this particular type of OpenSTAAD functions. So each and every operation can be done using this particular OpenSTAAD function. Might be you are interested to create some custom views, so that might be a huge structure and you want to work with a particular floor. So you can just select the floor and create some custom views using the OpenSTAAD function. You can also analyze the model or extract any results or information using the OpenSTAAD function. For example, like you have some in-house program which design the foundation of your structure. So for that you need the support reaction, and what basically we do, we can copy the support reaction from this particular post processing mode, and we can select the load cases, select the supports that we are going to the support reaction of which we are going to export. So that process can be automated using the OpenSTAAD function. So you can just write your code, you can just run your code, and program will automatically extract all the information, support reaction information, to the Excel or whatever program you are going to extract the value with. And also you can create your report there. So STAAD will provide you a report. You can generate the report from STAAD environment, but what if you want some more information? That option is not available in the generate report option. So you can just create your report using this particular OpenSTAAD function. You can just write your program there, just search for the proper OpenSTAAD function, write your program with that particular OpenSTAAD function, and once you run your code, it will be exported to any format like the Excel or the Word file. You can just submit your report using this has been created using this particular OpenSTAAD function. So now let's check about what are the common input output formats, or basically in which program we can write our code. So many programs can be used for that one. I basically show you an example of three types of input output formats that we normally day to day use. The first one is the STAAD interface. So as I have mentioned that there are several options available in STAAD interface that has been provided by the developer. But what if you need some more information, some quick information? So you can write your code. For example, like in this particular model, I have extracted the information how many number of members are selected in this particular structure. So for example, like you are going to perform some design and you want to check how many number of members failed in the first iteration, and you want to redesign and want to find out what are the number of members failed in the second iteration. So that can be easily done using this type of member information, or the printing the number of selected members information. You just need to write your code in the script editor. In the left hand side you can see the basic script editor that is available with STAAD.Pro. So you can write your code there, and you can just readily access this particular script editor or this particular code and get your information in the STAAD window itself. The next format is the text file format, or you can also write your output in the Word file also. So I have created one .vvs file, or .vvs file is a common format which we can access using this particular STAAD program. So I have written one code here, and what I basically in this example, I my intention is to extract the mode informations. What is the frequency of each mode, what is the spectral acceleration. I can just export those particular information in any text file. So I just need to write that particular code. I can just import that particular code instead, and that run that particular code, and all those informations will be stored in a .txt file that is created in the location where we have selected. So this is another example where we can extract our information, or extract our data in any text file format or any Word file format. And third commonly used format is that, and it is mostly used, is the Excel format. Yeah, we in our daily job we need to use Excel. In some cases we need to perform some design, and we have some in-house program that we have written in the Excel or similar applications, and we need to provide some inputs from Excel instead, and we need to copy and paste the information in Excel. After that, after once the analysis has been completed, we need to copy and paste the results from STAAD to Excel. Something like that we need to perform in our daily jobs. So that can be totally eliminated using the OpenSTAAD function that can be associated with Excel. So you can just write your code in Excel. All the inputs can be provided in the Excel environment itself, and once you run your code, STAAD will use that particular information to create the model, or apply the loading, or extract the reactions value or the force value, and all those informations can be stored in the Excel window itself. So you can just, using one click in your Excel file, you can just access all the informations from STAAD.Pro. So this is basically a very good use of Excel with using the OpenSTAAD function, and this can be useful, and I'll show you some example how this can be useful for our daily jobs. So coming to our basic point, is why it is smarter than the traditional approach. Consider about some aspects, like first, creating the geometry. We can create any type of linear geometry in STAAD.Pro easily using the grid option, whether that is a beam grid, or whether that is a plate grid, or whether that is a basic solid grid, that we can create in STAAD. But what if we are going to create some complex geometry like a tunnel structure using the solid elements, or some nonlinear shape like the elliptical structure or the dome structure? So what happens then? Normal practice, we can create the geometry in AutoCAD or MicroStation, and we can import that using the DXF format instead. But there are some limitations. Some file formats cannot be supported, some geometry cannot be imported instead. So those type of limitations can be overcome using this OpenSTAAD function. So for example, consider a elliptical structure or a dome structure. We know the equation of that ellipse, or we know the equation of the circle or dome. If we can write our code there, we can create some inputs about that particular ellipse, or might be the dome or the circle. We can write some math functions, so that those particular geometry points will be created, and those particular geometry points can be imported instead using this particular OpenSTAAD function. So we don't need to create and copy and paste everything, or create a geometry in the CAD files and import the model, something like that. We just need to provide our inputs there. We need to write our code using the math functions, relevant math functions, and all the information can be imported instead without any problem. So this type of complex structure can be handled more easily using the OpenSTAAD function. Or about consider about the instant information exchange from STAAD that I have shown you, like the select any member, the number of members selected there, or the number of primary load cases or the load combination cases present in any structure. That type of information can be extracted from STAAD using this particular OpenSTAAD function. And mostly that I have mentioned in my first slide, the options not available. So some specific options has been provided to any software similar. Instead we have provided some options. What if our requirement is not fulfilled using this particular function? For example, like that, in my career I have requested by so many users that why the moving load X and Z components are not available. So we have for moving load instead we have the y component of loading, and we don't have the y increment value. Also we have the increment value in x and z direction. So this type of limitations can be achieved using this particular OpenSTAAD function. This is a very good example of the moving load components, and I'll show you how to create the code and how this can be useful for our jobs. Next might be the repetitive job. If you want to compare the design results for same situation models but with some change, for example like that, a model with X bracing or a model with K bracing, what you need to do, we need to create different models, we need to analyze the models separately, we need to copy and paste the results from the post processing file in Excel file, and we need to manually do that all comparison thing. So this is a repetitive job. For each model we are performing same steps again and again. So this repetition can be eliminated using the automated programs. So we can just inform the program, okay, these are my models, you need to analyze the models and you need to extract the value and you need to compare the results. So program will do the repetition for you. So this type of repetitive job, for this type of repetitive job, I think OpenSTAAD function are the best options that can eliminate your repetition, and also that will reduce your total working time for any model. And yeah, interaction with the any third party software. So you, if you have some program that you have written for the foundation design or the deep beam design or any specific type of member design, probably like for steel structure you have some cruciform section, and that cannot be designed at this moment using STAAD. You have written some in-house program which can handle this particular situation, but you need the member forces for that or the support reactions. So you need to get that particular information from STAAD window to run your in-house program. So that can be used using this particular OpenSTAAD function. You don't need to copy and paste the values from STAAD. You don't need to filter the values, what should be our highest maximum positive or negative bending moment value or the reaction value. You can just extract the value in your program, you can just filter the value, and you can just design with the maximum value. So this is very easy. Using this particular option we can basically optimize our program or that we have created, and we can just readily data transfer using with STAAD.Pro. And another option that is not available in STAAD but that we can achieve, that is the optimization of the structure. Optimization means basically the main motto of the engineers is to reduce the total weight of steel or weight of concrete that is used. So we need to always, our motto is to go for a optimized structure with a reduced weight or the reduced used materials. So that can be done using the optimization. For example, like optimization of a truss. When we are going to create a truss member or that roof truss, we don't know about the angle that is the optimum. So normally we start with a particular angle and think about, okay, so if I increase the angle by 1 degree or 2 degree, what happens? Should the structure will be optimized? Should the material utilized for the structure will be reduced or it will be increased? We don't know the answer. So what is our option there? We just need to create some multiple structure where we need to change the angle manually to find out, okay, this is my optimum structure. Say for example I start with the 15 degree and I found that 18 degree my structure, the material used for the roof structure is minimized. So this can be done using the OpenSTAAD Pro functions, and to write some, you just need to write some code there using proper OpenSTAAD function, and this can be done easily. So why this is basically better than the traditional approach? I know most of us believe that why we should devote our time to write some complicated code. We need to find out what are the OpenSTAAD functions, how to write a code. So why it is beneficial than my traditional approach? I perform the analysis in STAAD.Pro window. I copy and paste the value to my software, probably in the Excel or an in-house software. So why it is better than to write a OpenSTAAD function, OpenSTAAD code with so many effort? So believe me, if you write one OpenSTAAD code that will be beneficial for your job, it is more better than your traditional copy and paste approach or the geometry creation using the copy paste approach. How it is better? Think about a situation that I have mentioned earlier. You are going to compare some models. So for each model you are going to perform same steps over and over again. This type of things can be eliminated using the OpenSTAAD function. OpenSTAAD, if you write one particular code using the OpenSTAAD function, that can be used for n number of models. So you might take some time to create that particular OpenSTAAD code. But if you think about the total lifespan where you are going to perform this particular same job, in overall time span, the OpenSTAAD code will be much more beneficial. One single OpenSTAAD code can be used for n number of models. So for the next models, you don't need to write your code once again. You can just use that old code. Yeah, program limitations can be tackled, that I have mentioned earlier, that there might be some limitations to each and every program. Yeah, instead also we have some limitations. We are trying to just overcome that particular limitation, and we will provide some options to the user that they are requested for. But for ready situations that yeah, I need this particular options right now, that is not always possible. So that type of limitations can be handled using the OpenSTAAD function, like the moving load y, x and z component values. Manual error can be eliminated if you copy and paste the values. There might be some error, you if you missed, if for your any mistake there may be some elimination of any values or digits, that can be easily eliminated using this particular OpenSTAAD function, where we are exporting the results directly from STAAD and just save it in any other programs. So this manual error can be eliminated. And finally, the off work hours can be used for the batch running. Means suppose you are running a large model that might be a G plus 20 story building or G plus 50 story building, where you have specified so many plate elements to create the slab, to represent this particular slab of the structure. And if you run the model, you will find that it will take 4 or 5 hours to complete. So if you change anything in the model and run the analysis, it will take all of your working hours, and finally in the afternoon you can find the analysis is completed, but you don't have the time to check the analysis results or the design results. So this type of situations can be eliminated using the OpenSTAAD. Think about a situation: you have the same model, but you have changed the missing element size, or you have the same model where you have changed the column size. So you need to find out what is my optimum structure. So you need to compare the results, and each of this particular model will take 4 to 5 hours to complete the analysis. So what you can do, you can just create all the models before leaving the office, just start the analysis using the OpenSTAAD code, and next morning when you arrive in the office, you will find that all your analysis has been completed and you have the analysis results. So you have the whole day to check your data and compare the data and find out what is your optimum model. And if you are not satisfied, once again change the model, start your analysis in the afternoon before leaving the work, and next morning you have the analysis results. So these off work hours or the idle hours can be utilized using this type of automated programs that can be written using the OpenSTAAD function. So I think this is very good use of your total hours or working hours, and this is a good example to why we should use OpenSTAAD function rather than the traditional approach. So let's see some program what I am talking about till now. First, let's start with a very basic example of creation of a tunnel. So solid elements can be created in STAAD, but there are some limitations. For any solid 8 noded solid elements, you need to select the nodes first. You need to select the nodes wisely so that the model can be created properly. You can think about creating of a tunnel structure where there are a number of solid elements are used and also in the circular form. So it is very difficult. So that can be done using this particular type of OpenSTAAD function. So I just want to create one particular tunnel structure, circular tunnel structure with this particular information. So I am going to save my model in this particular location. Say my model name will be tunnel 1, and these are my inputs that I am going to create the tunnel with this particular inputs. So what will happen? In the background there is one OpenSTAAD code is running. This is my OpenSTAAD code. So if I click on this particular generate tunnel option, the model will be created. So let's see how this particular thing works. So this is my STAAD file. So if I click on the generate tunnel option, it will create a STAAD file with this particular name that I have provided in the particular location that I have selected. And you can see in the background this particular tunnel structure has been creating by the program automatically. Those are basically the solid elements, and this is a circular format. The length of the tunnel is specified as 40 meter with a division of 10 divisions, and the circular radius is specified as the external radius as 10 meter. So you can finally find that this particular tunnel structure has been created. The program has been used for this one, this particular Excel file program. So this is basically my tunnel with a 40 meter length and 10 meter radius tunnel. So this is created, and you can find that each solid element has been created for this particular tunnel. So creation of this particular solid is pretty complicated, and you can think about creating this particular circular geometry using the normal manual approach. So it will take some time, but you can find that within few seconds I have been created this particular tunnel structure using this particular OpenSTAAD code. So this is a very good example where we can use to create some complex structure using this particular OpenSTAAD function. So let's think about the second scenario where we can use the OpenSTAAD function. Uh, for any complicated structure like the dam or like the retaining wall, we need to create the solid element rather than using the plate element. But what happens if you have a model where there is an opening? Creating an opening in solid element is very tough, because you need to locate that opening first, and then you need to create that particular model. So but you can just readily create that particular model using the plate element, because for plate element creation you have the parametric model option, where you can create any type of hole, or that may be circular, that may be octagonal, or any other shape. So creation of a hole is very much easy. You can create that particular using the plate mesh option, and also there is no option for solid meshing. So whatever element you can create, that might be your 4 or 5 options that is available in STAAD.Pro for solid elements, but there is no option for solid meshing. So you cannot create a whole solid block and you can mesh that particular solid block to create small solid elements. So that is pretty complicated. What you can do, you can just write your code, and you can just extrude this particular from this particular plate element. You can convert this plate elements to solid element, or you can rather create the solid elements using this plate element data. How we can do that? This is the code that I have written using the OpenSTAAD function to create solid element from plate element, the extrude.vvs. This is the vvs file, and I am going to use this particular vvs file to create that particular solid element from this plate element data. So what I need to do, I need to select the plate elements. Suppose I want to extrude this particular portion of this particular structure. I need to create the solid elements in this particular portion, and what I need to do, I just need to run this particular code. So if I run this code, it will ask for some information like the number of elements, layer elements. So say I have 2 layers and thickness of each layer is 0.5 inch. So basically this is created in the inch unit, and you can find that in the background the solid elements has been created automatically from the plate meshing. So first, if you need to create any solid structure, you can just create the plate meshing using the parametric model option or using the finite element meshing option that is available in STAAD, and you can just extrude your structure, or you can just create your solid element from this plate element meshing option. So you can find that program is automatically creating these particular solid elements, and this particular information or this particular plate information and the plate meshing data has been used to create these particular solid elements. So it is basically almost completed. So once the solid element creation is completed, you can find that it is perfectly in shape and with created with the data that you have provided as the inputs. So at the right hand side you can see that some nodes has been created automatically, and using this particular node informations, this particular solid elements has been created. So okay, your extrusion is complete, so it is ready. And if you view this particular 3D structure, you can find that okay, for this portion you have created this particular solid elements, the two layer solid elements with 0.5-inch thickness. So this is created. And if you think about creation of this particular hole in a solid structure, it is very tough. So you need to find out what is your node coordinate at this particular hole location, and you need to create your solid elements, and you can find that the solid elements are meshed properly. So you can find both triangular and octagonal and every type of solid elements that has been used in this particular meshing. So this is a very good example. If you work with your solid structure in your daily jobs, I think OpenSTAAD is your very useful for you. So next move to our next example that I'm going to show you, that I have talked about in so many slides, the moving load creation. So this is my structure. Think about a ramp structure, or a bridge structure, bridge abutment structure, where the car is moving not in the horizontal direction, rather in some angle with the horizontal direction. So first question is, can you do it using the moving load option that is available in STAAD? The answer is basically no. So if you go to the loading and vehicle definition and add one particular moving load, you can find that you have the loading, you can apply the load in basically in the vertical direction. And if you think about the increment of the load, you can find that only x and z increments are available. So basically you cannot move your moving load in the angular direction, but using some OpenSTAAD function you can generate this type of moving load easily. So what I am going to do for this particular model, you can find that there is no loading has been added yet. So I am going to create a moving load in this particular structure. The load will be moving in this particular direction, so it will travel in the horizontal direction for this particular beam. So it will travel along with beam number 6 in the horizontal direction, and after that it will just start climbing using member number 1, along member number 1. So let's start our code there. So this code, I have written this particular code to generate the create the moving load, also extract some results. So suppose 8 number of loads has been created, so I'll readily analyze this particular structure and get that particular what is the maximum positive and negative moment values, and what is the location of this maximum and minimum moment values for any particular load case that I have created. So this is basically a combination of input and output. You readily create the loading in your STAAD model, or you apply the loading in your STAAD model. After that you analyze the structure, and after that you are just extracting some results as per your requirement. So this whole can be done using a single click of this particular button. So prior to starting that one, I just want to check how this load is created. So I am just switching off the analysis part of this particular code. So I'm just switching off the analysis part. So if I click on this particular, you can find that there is no load still applied on this particular structure. So if I click on this particular load, so the load has been created. Let's see how the load looks. If I go there in the loading page once again, you can find that load has been created. So this is basically the load has been created for member number 1. So you can find that the load has been created in global y direction. This is my direction. The load is applied, the load value is mentioned here, the increment value is specified here. So for member number 1, I have specified the load increment as 0.5 meter, and the load value in the y and z direction has been provided as -10 and 5, and the load is applied in the y direction as in the global direction, and for z in the local direction. So basically this is the load that has been created in global y and local z direction. So this is the loading, and you can find that the load is moving in this particular angular direction. So how it will look like if I move the load in along member number 6. So I just need to change the member number here, member number 6. Okay, and suppose I want to move our load, or I need to apply the load in the global z direction also. So this is basically for this horizontal member, I'm going to apply the load in the global y direction and also in the global z direction. So just click on this one, and for this type for this particular part, suppose I want to extract the results for say the load number 5. So I need to also just extract what is the result. So if you click on this one, I'm just going to click on this one. Okay, sorry. Okay, you can find the analysis has been completed and all the data has been extracted. So for load number 5, what is my maximum moment value in the z direction, and what is my maximum moment value in the y direction, and what is the location of this maximum and minimum moment value, that has been reported here. And if I look in my structure, let's see what loads has been created. So basically this loads has been created for this particular angular member number 1, and this load has been created for my member number 2. So if I look at the bending moment diagram, so this is my basically bending moment diagram, and you can find the load is moving. So this is the loading. So the load is moving, and along with you can see the change of the bending moment diagram. So basically this code is created to represent how OpenSTAAD function can be used more efficiently to handle some of the limitations that we have currently. We don't say as limitations, during implementation of any each and every feature, our development team think about some of the scenario, that some of the scenario might be case specific, so that has not been included in the default option. But this type of specific situations can be handled using this particular OpenSTAAD function. So this is a very good example where we can use the OpenSTAAD function to apply some loading on our structure. So let's see about some other options like the intermediate force value extraction. So as I was saying, that if we are going to perform some design, we might have some in-house program, or we might have some created some Excel file where we have specified our all the codal provisions, and we have written already there. So what we basically need, we need basically the member intermediate section forces value, and STAAD don't have any member intermediate section force value reporting for the 12 sections. So if you go to the post processing file, you can find that the section forces are reported for 5 sections, so start and end and intermediate 3 sections. But you need the section forces for 12 sections to design any member. As for example, like a dip beam, we do not perform the design of a dip beam. You need the 12 sectional force values for this particular member. So what you need to do, manually you can just add the section command. So if I look at this particular structure, I have included the section command there. So for each section, maximum 3 number of section command can be added. Section can be added in the section command. So for 12 section, I have to include 3 or 4 number of section command. I have to assign that to the proper member, and in the output file we can find that those sectional forces have been reported there, and we need to copy it from there. So we have to perform so many steps just to get the 12 intermediate section force value. And what if I create any create any code with this particular sectional force in extraction? So what happens then? Let's see my code here. So I have created this particular code to extract the sectional forces for any member. I need to specify this particular member number there only, and this is my code. So suppose for example I need to print out the value for member number 1 and for load case number 1 for 12 divisions, or say 14 divisions. I need to extract the sectional force value. So just analyze the model and just run your code there, and you can find for all 14 sections all the sectional forces value are extracted here for that particular load case. Now think about all the load cases. You can just write your code there, and you can just add another loop to extract all the to consider all the load combination cases and the primary load cases. So using this type of codes, you can just readily extract your values very easily without any problem. So that can be helpful for your job also, or basically this type of jobs can be done using the OpenSTAAD function, like the support reaction extraction, And finally, the multiple analysis. So let's say we are going to let's first open my code. What my intention is to compare the results of these particular two models. So these are my models. They are basically the similar. One is with the K bracing and one is with the X bracing. So I have two scenarios. The same loading has been specified here, and what my intention is to compare the results and to find out what type of bracing is suitable for this type of loading and this type of structure. Okay, so what I need to do, we need to compare. If we want to perform this manually, we need to analyze the structure, we need to copy the utilization ratio from the post processing table in the Excel, and we need to manually compare the results. And what will happen if I just use any this particular OpenSTAAD function? So this is my particular file that I am going to use for this example. So I just need to copy replace the existing folder that I have created, that I have used previously. So this is one of my model and this is my second model. So I have specified the folder path. One is my kbrace and another one is my express structure. And what will happen if I run this particular code? So let's see what will happen. So if I click on the compare ratio, you can find first the k-bracing model has been opened, it has been analyzed, and all the utilization ratios has been extracted to Excel. Next, it will go for the x-bracing structure, and similar things happen. It has analyzed the structure and it has compared the results. So it is readily available for you. You can find that for member number 3, for k-bracing structure, the utilization ratio is 0.47, whereas for the expressing structure it has been 0.465. Similarly, you can compare the design results very easily. So before leaving your office, you can just paste your path of the folder where the files are located. You can just analyze, just start your start running this particular code. And yeah, basically this is a very simple model, so the analysis take to less time, but might be for your case the analysis took so long time. So in the next morning you can have this particular type of Excel and you can have the analysis result where from you can compare the results. So this type of things can be easily done using the OpenSTAAD function. Automation is the very good option where you can utilize your work hours easily. So these type of things can be done using this particular OpenSTAAD function. And basically I need to show you another example that can be created here. For example, like I have selected this particular jobs, this particular sections. So I need to find out how many numbers of members are selected. So think about a basic very large model. So I can just add my code in the user tools, and I can just click on this one and it will provide me the number of members selected in this particular model. So if I go to the post processing file and if I find that okay, some of my members fail, I can check it from here. So failed members, how many number of members failed, I can check it from here. Just copy this one and I just run my code, and okay, here is my code. Here number of 35 number of members failed. And next iteration might be I change the section size and once again go there and find out how many number of members failed. So say that next time 25 number of members fail. So I find that okay, if I change the section size from this to this, 10 number of members pass. So next time I might go for a larger section. So these type of things can easily be done using this type of OpenSTAAD function. So these are some very basic examples that I want to show. I don't have much time for left for this particular session, so quickly go back to my presentation slide. If you are interested to use OpenSTAAD function, where from you can start. So there is a location where we have some sample files. Like the location is your in the public documents where the sample files of STAAD are available. You can find an OpenSTAAD folder there where the samples files are located. You can start your work with that one by just reviewing what are written there, what are the functions has been used. If you want to get any OpenSTAAD help, if you just go to the welcome screen of this is basically the STAAD.Pro Connected Edition version. If you go to the welcome screen, you can find the OpenSTAAD help option available there. You can just you can just readily launch your OpenSTAAD documentation from where you can check what type of OpenSTAAD function you need to use. So you can find your relevant functions from here. And finally, if you want to get support, get help and support, you can just dial the toll-free number or anytime you can create the service request, or you can also post your queries in the B community site. So that is a good forum where you can discuss about what type of code that you are going to create, or if you face any problem or if you need any help, you can just post your query in the B community site. So that is a very good option there. So with this I am just concluding my session. So I just want to mention that this is a recurring session. So each month I'll conduct a OpenSTAAD session with some more examples, with some more information. So in my next session I'll start with how we can generate the OpenSTAAD codes, basically how to select the OpenSTAAD functions, how we can just generate our code. Probably with I will start with the Excel, and so just keep a eye on the events page of Bentley, and probably you will get an email also from the Bentley side, from our side, and just register, and you will attend the next session where I am going to discuss the more about the OpenSTAADs. So with that I am just concluding my sessions.